Hello friends, the topic of discussion in this video is the insertion in a linked list, in a single linked list. So insertion in a linked list is the topic, and we are going to write a C function in order to implement this insertion in a linked list. So insertion means, I will just give you a graphical, the pictorial representation to make you understand what I am going to do in this video. So let me just write a linked list. Let me draw a linked list and then show you what I want to do over here. Suppose this is a linked list. Suppose this is a linked list. This is a singly linked list with a P list pointer. Here is an address 65586, 65536, 65596 or something like that. There are some elements over here 10, 20, 30, something like this. Here this address will be stored over here, this address will be stored over here, as you all know, and now there is a null pointer over here. So insertion in a linked list means that if we want to insert any node at the beginning or in between in any intermediate position or at the end, we can resort to this function which I am going to write in a bit. That function will help us to insert any list at any position in a generalized way. It is a generic function which I am going to implement, which can be used to insert list at the beginning, at the end, or at any intermediate position within this linked list. So if you want to insert it here, I can well insert it here. If I want to insert it here, I can insert it here. If I want to insert it in between these two or in between these two, we can insert there as well. So our function will be a generic function. I will just use a C programming language in order to write the function. So let's get started with writing the function, and then I will explain what I have done in that function. I'm not going to return anything from this function, so I'm going to take the return type as void. And I am going to write the name insert, void insert, or you can write any other name of your choice, void insert, and then I am going to take a pointer, a node pointer. Suppose a node pointer, I will just declare the structure of the link of the node in order to specify type def struct node. Type def struct node int data and struct node star next. This structure definition has been already discussed in other videos which are related to the linked list. So you can refer to that structure declaration as well, but I am just going to remind you once again of that. So I am writing this structure over here, type def struct node int data, that is the data part, and this is the pointer part, that is the address part. Struct node star next, and now I am going to write this as node. Now I am going to take this sort of pointer in the argument as node star p, node star p, p is the pointer to the type node, then I take int I, and then I take node star t. So what I have taken over here, I have taken three arguments, three parameters in this function definition, where we have taken two pointers or to the node type, that is node star p and the node star t, and one integer variable I, and that integer variable denotes in which position we want to insert the node in the existing linked list. That is, I can be 0, that is the 0th position, that is at the beginning. I can be 1, 2, 3 as well, and I can be any other non-zero numbers. So that I is the position of the new node to be inserted, and the pointer to the new node is taken to be node start t. Suppose the node is created, and that node will have to be inserted in the linked list at any position starting from I is equal to 0 to other non-zero values. So these are the three arguments. Now we start writing the code. We can take node star q star x, and we can take another integer variable int j. So int j node star q node star x. Now first our objective is to see whether the node can be inserted at the beginning. Suppose this is the linked list. Let me draw the linked list over here. Suppose for the sake of simplicity, I am drawing 3 nodes. So these are the 3 nodes of the linked list. This is suppose 655, this is 659, this is 757, something like this. This is the P which points to this 655 memory location. P is equal to 655. It is 659 and this is 757 and this is null pointer. Here there is a data called which is 5, there can be 10, here can be 0 or something like that. So this is a existing singly linked list in which we want to insert the node P at any position. Suppose first case which we are going to deal with in this function is the insertion at the beginning, that is in this position. That is, that position will be taken as the 0th position, I is equal to 0. So if I is equal to 0, so after insertion the linked list will contain 4 nodes, out of which the newly inserted node will be the first node of the entire sequence, and the P pointer, the list pointer, will be pointing to this newly inserted node which is taken to be node star T. So now if I write that portion like this, if I equals 0, then what will be the operation? This T, suppose T is this one, suppose this is T. T is the pointer pointing to this memory location. Suppose this is the memory location 555 or 557 maybe. It may contain a data, suppose it may contain a data of 2. This has a null pointer in it. So it is not linked to the linked list. It is a standalone node. This 557 numbered node is the standalone node containing the data value 2 and a null pointer. So this is to be linked to the existing linked list. This is to be made a part and parcel of the existing linked list and is to be inserted at the beginning so as to make it the first node of the entire sequence. So in that case, what will be the pointer changes we have to make? We have to write those pointer changes over there. Suppose, see this, if we want to link this node to this node, we will definitely have to incorporate this address value into this position. So this is the T node and T has the 2 parts, that is T data and T next. So T data contains 2 and T next is containing null at the beginning. But now I have to do one operation so that this 655 comes over here. So T next will become nothing but P. So I will write like this, T next is equal to P. So T next is equal to P means this null pointer goes off and this is linked with this one. So it is added to the existing linked list which was there with 3 nodes. Now this linked list becomes a bit larger containing 4 nodes. So the newly inserted list node is at the beginning of the linked list which was existing before. So this is the operation we have done. Another thing we have to do that, since this becomes the first node of the entire sequence, I have to update this list pointer from pointing to this position to pointing to this position. So this P is to be updated to this T. So I will write this operation, P is equal to T. P is equal to T means P never points to this position. P now does not point to 655, the address 655. It will be pointing to the memory location 557. That is, T is pointing to 557, P is also going to point to the same memory location, and in this way we have shifted the list pointer to the beginning of the linked list so as to make it a perfect list pointer. So P is equal to T, and after that nothing is remaining in this situation, so we are going to write return. And we are not going to perform the remaining operations in the code because we have done our job. But if the other possibilities arise, like we are going to insert the node at any intermediate position in the existing linked list or at the end, so in that case we will write a generic piece of code outside this if block, and that I will explain later on. Let me write the code first and then I will explain it. So I will just rub off this linked list a bit like this. I will just rub off this portion and keep it in the way as it was before. So I will write like this. So this is the P. Then suppose I is given by the user to be, say, about, this is the 0th node, this is the first node, this is the second node. Say suppose user wants 0, 1, 2. Suppose the user gives a value of 2 to the I variable. So we are going to insert the newly taken node, that is pointed to by T, in the number 2 position. That is, this is the 0th position, this is the first position, and this is the second position now, but this will not be the second position after the insertion. After the insertion, the newly inserted node will be placed at the second position, and this will be the third node in the number 3 node in the entire sequence starting from the 0th node. So in that case, first I have to take like this, I have to write like this, Q is equal to P. So Q is equal to P means we are pointing this Q towards the same memory location as P is pointing to, that is 655. So P and Q are both 655 in this situation. After that, we will write a loop like this. For j is equal to 1, j less than I, and q not equal to null, then j plus plus. Then we will write a single expression statement, q is equal to q next. What we have done over here, let me see. For j is equal to 1, j less than I, ampersand means the logical AND operation. That is, these two conditions should hold at the same time, otherwise this for loop will not be executed. So this j less than I, ampersand q not equal to null, and then j plus plus, we have written only one expression statement under that, that's why I have not used any brace over here. So q is equal to q next is the line. So what I have done here, let me see, j is equal to 1. So j was taken to be a variable over here and j is initialized to 1. Then what is the value of I? I value is 2 given by user. So definitely I1 is less than 2. So j is less than I, and let me see whether this condition holds. Q is equal to P we have taken, that is Q is at 655 pointing to 655. Q is not at all null, so it is not a null pointer. So these two conditions hold, and now we can enter the loop and do this operation, that is Q is equal to Q next. What is Q is equal to Q next? Whatever is in the Q next position will be assigned into Q, and in this way Q will be updated. So what is the value of Q next? Let me see. Q next contains this value 659. So Q next, now Q will become 659. So Q will become 659 means that Q will not be pointing to this location but will be pointing to this location. So Q will now be shifted forward by one position. So in this way, we have to see whether we reach our desired position. Suppose, let me see whether we have reached our desired position. So let me see whether we have moved to the desired position. Suppose I is equal to 2. Now, after going by one place forward, then we will increment j by unity. J becomes 2. 2 is never less than 2. So this condition never holds. So this condition doesn't hold. So we need not check the other condition because it is a logical AND operation. So we will stop our iteration at this position after just going through the loop once. That is, the iteration will take place only once. So in this position, in this case, so we have moved Q by only one position forward, and Q is now pointing to this 659 location. Now let me see whether we have moved to the desired position. How to determine that? See this, what is our objective? What was our objective? That is, insertion of the newly inserted node is to be inserted at the position which is 2. That is, starting from 0, the position 2. That is 0, 1, 2. So this is the 0th position. This is the number 1 position, and the newly inserted node will be number 2 position. So we have moved as far as the location number 1, this was the 0th position, and after that, see, we are going to insert this node star T in between this number 1 and number 2 node in the existing scenario. So that will become the number 2, newly inserted node will become the number 2 node in the sequence after updating, after inserting. So we have definitely moved to the desired location. In this case, now what we'll do next, let me write the piece of code. Again, I will write 2 lines of code or 3 lines of code and I'll explain it to you. Suppose in this case, we have to check like this. If Q equals null, and I greater than 0, we have to put a check over here. What is this? What is this code I have written? Why I have written this code? If Q equals null, double ampersand, that is logical AND, I greater than 0. If I has a value of non-zero value, then we are definitely dealing with a case which is not belonging to this if block. So we are definitely dealing with the other cases apart from this I is equal to 0 case. So I greater than 0 means a non-zero case, that is looking to be valid up to this portion. But see, this is another thing to be noted, that Q equals null means we have moved Q to any position beyond the linked list. So if we move the Q to any other position beyond the linked list, suppose if we want to insert the node at 4 position, in this linked list this is not possible. See this. This is the 0th position, this is the 1st position, this is the 2nd position. Maximum we can insert the node at the number 3 position in the existing situation. That is the last position. After that, there is no question of insertion after the last position. So there is no question of insertion at 4 position or 5 position or 6 position or something like any higher values in this situation. So in any situation, if we go on to see that this iteration takes the Q to some extent which goes beyond the existing sequence, then we are left with no possibility of insertion at that particular circumstance, at that particular case. So in that situation, to just avoid that situation, we have taken this checking thing over here. That is, if something goes wrong, that is, if the user by mistake has taken I value to be 4 or 5 or 6 or any other higher values, then in this case, in this scenario, there will be no possibility of insertion. So in that case, I will just go on to write a expression statement and expression statement return. That will take us out of this function. That is, we are not going to perform any insertion operation in that function, because that is an invalid case. So in order to rule out that, in order to take care of that invalid situation, we have resorted to this section of code. So it is a very important point to be noted, friends. Please take it down, so that, please note it down, so that you can just put this checking in order to write this generic code of insertion. Now, if this is not the case, that is I is 2 or I is 3, that is at the last position we are going to insert in this case. So in this case, I is equal to 1 is also a valid value, because we can insert definitely at this position, between this zeroth position and the first position. So valid values of I which are non-zero can be, in this case, can be 1, 2 and 3, and beyond that it will become an invalid case for which we have taken care of that situation by writing this piece of code over here. So in that case, we are going to return, and in other cases, valid cases, non-zero valid cases, we have to insert the linked node, insert the newly created node at the desired position as desired by a user. So for that, we have written so far, how much we have written? Q is equal to Q next. We have moved to the desired location. In this case, we were dealing with the value of I is equal to 2. So that is a valid case, because it falls in this valid range, that is 2. So we are now at this position. Q is now at this position, that is pointing to 659. And now we have moved to the desired position, because Q is equal to Q next. We have executed only once, as we have shown before, as I have shown before. Now what I am going to take is, what I am going to write here is that X, there is a pointer which I have taken before, that is node star Q. Along with that, I have taken a pointer which is X. Now I will take X is equal to Q. X is equal to Q means, now Q is at 659, so X will be pointing to the same location, so X will also contain 659. Correct? So this X and Q are at the same position. Now what we have to do, see, that is X next. X next. What is X next? X next is nothing but Q next. That is, X next is 757. And X next will now cease to be 757, because 757 will not be pointed to by this node X, because the newly inserted node will be inserted at this position. So the X next will contain the address value of the new node, and the new node is, suppose here it is at 505 location, containing a value -3. It has a null pointer, and this is the node which is the newly created node which is to be inserted, and this is pointed to by T, and this X next will now contain the 505 value. So X next will contain what? T. And what will T next contain? T next is null pointer. So T next is null pointer, and this is to be linked to this node. So before updating X next, we have to do this operation first. So X next, so T next will be nothing but X next, that is 757 will be written over here, so that this null pointer is going to be ceased to become a null, to remain a null pointer, and it will just point to this 757 memory location. So 757 comes over here, and then after that we will go on to update this X next value to be pointing to T. So in this way, see this, the linked list is pointing to this node, this node is pointing to this node and this node is pointing to this node. So it is inserted logically in between these two nodes. So for that we have to write only 2 lines of code. I am left with 2 lines of code. So I am writing the 2 lines after x is equal to q over here. So because there is a paucity of space over here. T next is equal to x next. What is T next is equal to x next? T means this one. I have already explained it to you. T means this node. So T next was null before and now is to be updated to, that T next value is to be updated to x next. Whatever was in the x next, that is 757. So 757 will be assigned over this T next position, T next value. So this pointer never points to null now, it points to this node, that is 757 numbered node. And after that, what we have to do, since both of these nodes cannot point to the same location, that will not be a proper sequence in a singly linked list. So this is to be reassigned by which value? It is quite evident that this is to be linked to this newly inserted node T. So now x next will be updated to T. So the code will be x next is equal to T. That means this 757 will not be here. It will be 505 because it is going to point to this position. So the list becomes like this. So the newly inserted node is inserted at the number 2 position. In this way, you can insert this newly inserted node. You can insert this node at this number 1 position, at the number 3 position. But beyond that, it is not possible in this scenario. So that brings us to the end of this function definition. I will just write a return statement and end the function with this closing brace. So if you have any doubts or queries, friends, relating to this entire explanation, you can well post your doubts and queries in the comment section below so that I can address them. Thanks for watching this video.